Okay, I hope everybody can hear me now. Thank you so much for joining our stream. For special shout out to those that joined our last stream that got cancelled due to technical issues. And if it's your first time, welcome. And I see that a lot of people already joined. My name is Anya. I'm a business development manager of Kmine. If you haven't already, please follow our LinkedIn page. We will put it on the link below. And we will post our future announcement on our LinkedIn page as well. So just to refresh, as this is our second attempt, hopefully everything will be okay this time. Today we will talk about our scheduling model. We also will have our guest speaker. It's CEO and founder of Argilas, our partner in Brazil. His name is Gabo Machado. Gabo, do you hear me?
Hello, everyone. Yes, I am here. Can you hear me well?
Yes.
Okay.
Hopefully everything will be okay. Also here with me, Eugene Chernichenko, who is a mining engineer at Kmine, and he will answer your questions at the end of the stream. Eugene, do you hear us?
Yeah, I can hear. Hello, dear colleagues. Glad to see you all on our stream. I wish you a pleasant viewing. It will be interesting.
Great. So just a quick breakdown of how this stream will go. Basically, this stream will be recorded, and if you know anyone who would be interested into this functionality, feel free to send a recording later on. And basically, just to give you the overview of what we do in general, Kmine have been on the market for over 25 years. We have been creating models for underground and open pit mining. Currently, we have created 15 of those. During this time, of course, we had a chance to work with users of our competition, such as users of Vulcan, Surpac, and Datamine. And sometimes we actually switch users from these solutions to our application. And basically, by switching them, some of our users told us that they were able to benefit from our algorithms that are more precise in terms of estimation, in terms of forecasting, and of course, that all contributed to reduction of the expenses and boosting the production level in general. So again, we'll talk about today about our scheduling model, but first I would like to give the floor to our guest Gabo, who will tell you more about his experience with similar softwares that provide similar functionality, and we talk about more about trends that currently in place for planning and scheduling software. Gabo, the floor is yours.
Well, best of greetings to everyone, wherever you see that you are, whatever time is it for you. Un saludo a los hablantes de español y un grande abrazo a los portofalantes ahí. You may feel free to jump in with any questions in either Portuguese or Spanish. That is the main target today. We want to bring up what Kmine has to offer to Latin America in general, right? So to tell you a bit about the background and current trends of this amazing topic, I have a slide presentation, shouldn't take more than 10 or 15 minutes. Please do let me know, Anya, if my screen is properly shared and if you can see and hear me well, okay? So here you go. Can you see that? Is it good? Am I good to go? Okay, I think just, okay, wait. Let's Civil configuraciones alternar. Okay, so I assume you're seeing me well. Okay, I'll go ahead. So first of all, as Anya mentioned, I am the founder and CEO of a clay technology startup. I am myself a mining engineer with many years in the industry. I'll go right through that. Right. So this is what we're going to be seeing in our presentation. And I'll begin with who is it that we are. Right. So Carmine has already presented themselves. As for Argilos here in Brazil, we are currently working with Carmine. We represent them, but apart from that, we are a sustainable driven startup that provides sustainable solutions for environmental remediation in the mining industry, right? So I've been 20 years in the industry, 10 years in operations, another 10 in research, right? Going through many countries, you can see there in the list. And these are my partners at the company, okay? So just to get into the theme, okay? So what you're looking at there, and now we're going to be talking about the roots, the background of the topic today. And that is those pictures you see there. They're amazing. And they belong to Berre Metallica by Georgios, what's the name? Sorry, it's Agrónica, right? So it's the first, recorded mining plan 500 years ago, and it's an amazing document because you have an holistic perspective of the whole operation. You see, the first two small pictures to your right, they are the actual veins is a vein type metallic ore, right? And you see that there is, all aspects of the operation, going from mine design to metallurgical processes, and even there is, detailed descriptions of the tools that were going to be used after processing and separation of metals, right? So is a really nice document for us mining engineers to go into looking, and I believe it's the way we are going back to be working in planning. All right, I'll explain that afterwards, but keep in mind that this was an holistic mine plan. Okay, of course, it's been recognized as another kind of document. It's of course ancient engineering also reference, but I will make an analogy to this further on. Okay, so bit after that. In the 50s and 60s, or even 100 years ago, the punch cards were state of the art, right? And the initial roots of what we know nowadays as mine planning and scheduling were based on this principle. And in fact, the guy who invented the concept is a mining engineer who went for IBM. And then the Lean's theory was used for cutoff grade optimization. That was, the first initial steps of what we now know of mine on mine planning and scheduling, right? But then 50 and 60 years ago, the Lurch-Grossman algorithm was used for pit optimization, and it reigned for almost 30 years. It became almost mandatory until the 60-bit technology came around, and the first applications on actual modeling and all the applications associated to mine development were set up. What you see to your left is one of the first recorded or published 3D models in a relatively complex geological setup for a Cooper mine, and just to make an analogy, in '94, Mr. Nazarenko, who is the founder of Carmine, was already working on surveying tasks, automated calculations, and some graphic models. Okay, so. Recently, and in the early 2000s until 2010, probably, this is what it looked like. We were already working in optimal control determination, strategic operation planning, and integration to dispatch management. There is a large setup of tools and publications related to that, right? And we do these images that you see there are all from modern combined. It's good to keep in mind. But there was a shift from the Lurch-Grossman algorithm, who was, as I said, dominant at that time, to the direct block planning and designing, because it is naturally more fit for scheduling. You can imagine that the sequential nature of this block structure is of course more appropriate for short, mid-term planning. Okay, for a right planning setup. Okay, so now after this history of what we're talking about today, this is what came out. This is a general way of how the mining process goes around, and you see geological exploration and geological modeling as first stages. That's where the initial investment comes from, but also what justifies the investment for further activities. So only when you have that feasibility clearance, you may move to what is comprehended as mine planning, and then you have these two big steps, right? Mine design and scheduling. But the fact is that today scheduling sees all overall activities of the mining industry as parameters or even restraints, right, to design and scheduling. That means haulage, environmental aspects of the operation. They're all going to be looked as elements that would limit what you're going to be prospecting in terms of scheduling, right? And that has been coming like in an specialization wise with respect to that first mine plan I mentioned 500 years ago, right? So what is the trend currently, and what is the industry looking into? Okay, so here you go. This is what Bali has to say about it. You can see planning as a cornerstone of the whole operation, and all these other activities integrated into it, even those who are not directly linked, like topography or drilling. They are somehow associated to feed planning, but planning also interacts in a real-time adjustment fashion towards the rest of the mining cycle. Okay, so mines of the future will have a systemic management. Okay, more clear than that can't be. And then you see a similar approach for gold fields, right? And this is interesting because it's going to be linked to our next slide in association to mineral commodities scarcity, but also market trends. Okay, so you can see clear words like strategic planning and operations, or group strategic plan, and there is a lot going on in coal and let's say not sustainable mining, if you can use that expression, right? But the shift to zero carbon economy is making some minerals having more stress in terms of prices on market, right? And there is a lot of exploration going on there, and then others are going to be reduced in terms of demand and structure. There are trends like, for example, I'm going to be talking about that later on, but there is a trend in the corporate mining world to equilibrate their portfolio in order to balance their mineral assets, right? So this is what I mentioned before, mineral scarcity, and then you have different perspectives, four of them, right? So Japan, the European Union, US, and this was UK, I think, the first one. But anyway, you see that the list of minerals who are described as scarce or strategic or in danger, okay, varies from one area to another because it considered they do not have proper reserve in their own territories, right? And as a consequence, you see that the European Union has a larger list, right? As for the US, a shorter one, but they do already assemble in 2013 a kind of a look into electronics demand and the kind of materials are more demanded there, right? In the other graph you have to your right there, you may see a graph of ratios of global reserve as a function of annual global production, right? And that is a lot older. That is from 1984, but you already see reserves that only account for 10 years of demand. That means they should have already been run off, right? But it's not the case, okay? So you have to understand that this is measurements of real reserves, accepted reserves, right? And there is prospection always going on, right? But there is also other elements on other minerals that have been going deeper or lower into that range, like phosphate, for example, or even lithium, that all of you know are a key mineral for the zero carbon shift, right? So looking into another important trend, which is the decarbonization of the mining industry, you see, and I'm going to correlate this with the comment I made about Goldfields, right? And not just that company, many others also. I'm moving into that direction. Sorry about the motorcycle. I'm just in front of my house. And well, the fact is that you have a tendency to shrink coal and iron, all right, in terms of market size and revenues coming from those industries. And then you have new players increasing in size, right? Like lithium, cobalt, copper, uranium, and rare earth, of course. Niobium is not there, but I'm sure it should be. Okay. Okay, so the last trend, and possibly the most important for the topic we are going to be approaching today, it's of course the digital era in the mining world. And on top of the slide, you may see a real track and a simulated one, a digital twin of it. And there is a process going into or mixing artificial intelligence, advanced analytics, and real-time sensors, apart from robotics, in order to basically perform two types of routines. One, the simulation routine, and the other one is the prediction the tool. So imagine you have a digital twin to an ongoing mining operation. You can either look at this as an holistic mining value chain as a whole, or you can look into independent activities or stages of the chain, right? And then you may see that in a simulation stage, you now can do things that beforehand were unthinkable. Like, let's take the case of a blaster who wants to change the kind of explosive he's using, or even the pattern he's using. So he can provide this info to an operations manager, and he would be in a position to actually simulate with a digital twin and project all the implications that decision would have upon the final financial perspective of this same business, right? So you can see the implications on the, let's say, rock fracturing or projection as a function of load, and then haulage, and how you can influence the whole process, right? So that is unthinkable. That was unthinkable 20 years ago. Okay, and then on predictions, you can take decisions as a function of what your digital twin can drop. Okay, what you see beneath it is another kind of approach in which you have real-time sensoring. That is a water treatment cell, and then you have real-time monitoring of pH and adjustment of reagents. In this case, flocculants are real-time being dosed into the process, into the water treatment stage, to reduce costs because they are significant in terms of price and cost and financial implications. Okay, so this is what I brought here for you today. As I said, it's just a slight overview to give the introduction and floor to Anya and Carmine. Okay, thank you very much.
Thank you so much, Gabo, for your overview, and I'm sure we'll have some questions in the end. Now I would like to talk in more details regarding the specific functionality and schedule and the purpose of our scheduling model. Basically, this model is designed to identify the mining period of individual blocks and open pit areas to ensure the compliance of the requirements on quality, volume, and other technical standards during the open pit mining, which today we're talking about only scheduling of open pit mining. And basically, you can see on the video that the block model of the deposit becomes one of the main source data, which divides the entire deposit into the separate areas of a certain shape. Also, certain properties are assigned to each of these sections or blocks. In this case, we have created an artificial block model with data about an iron ore deposit. Block model contains about 4 million blocks. Each block of this block model has a cubic shape equals to 5 by 5 by 5 meters. And as you can see that the block model consists of different colors. It also displayed coordinates of each block center, rock code, total, and magnetic iron content in the block, rock grade, and weight. And in this case, the rock is, in this case, the rock with the code that is divided into grades. Besides the block model, our software also uses wireframes. Wireframes is basically three-dimensional shapes of the source data. They show which part of the deposit should be mined from the beginning of the first time interval to the end of the last one. You can use two optimal pit boundary positions previously determined by K-Mine pit optimizer model. You can take a look at if you missed that stream, you can take a look at that stream in on our YouTube channel or on our previous events. So anyway, we will put the link below so you can check it out later. So there is the first optimal pit boundary position on the screen, and then there is a second one, and we can consider the second optimal pit boundary as initial. It is located inside of the first boundary. And the first boundary, you can see it as a purple color on the screen, is the open pit position at the end of the last time interval, for example, for a year or a month. And you must mine this light area of the deposit and these blocks for a certain time interval. So basically, you can create several versions of the work schedule that differ in some source data. And you can store each of these versions in a separate project. For example, you can create your own project with a unique name and then specify the folder where the information about this project will be stored. All files with both of the source data and the calculation results are also stored in this directory, and you can create the tree diagram of areas with the source data, various objects, and numerical characteristics there as well. So this tree diagram is indicated on the left, and the block model is on the top level of this tree diagram. So now we're performing the block model calculation and the blocks we are going to mine. And then we calculate the number of mine blocks, volume, and weight of rock type in these blocks. If the rocks can be grouped in any way, then we can configure these groups, and we are setting the name for overburden, such as waste, and then specify that all rocks except 2 and 4 are overburden. And for the rock with the code 2, we are creating the separate ore type named K2. And for the rock code 4, we are creating the ore type named K3. So, by the way, for each ore rock, you can specify the qualitative parameters that should be considered in the calculation. For example, we're going to see now such parameters as total iron and magnetic iron. And as you will see on the video that we're going to show you right now, the part of the deposit which are the blocks, the block cuts from the block model, the part of this deposit is located between 2 wireframes. You can divide the entire set of these blocks into several sections. Usually when the open pit has been mined for some time and a certain set of sections is created within some zones or another geographical feature, and these sections are mined arbitrarily autonomously. So if you need to make sure that things like maintenance of the pit wall movement or on any specific sections, this movement schedule or pit wall preservation are important, then you must select these sections to make sure that they are scheduled correctly. And in order to create those sections, you can use one of the functions, specify the section configuration in the plan, and then rotate the image in 3D. Then you can set the restricted vertex heights for this section, and finally confirm the creation of the section. After the section is outlined and drawn, blocks that are cut from the block model should be grouped by their levels, and that's why you need to specify the range of its vertex heights, and in this case the level list is not created yet, but you can see on this example that one layer of the block model arbitrarily corresponds to one level, and you can see on the table various statistics on things like average total and magnetic iron, the number of blocks, volume, weight of the entire level rock type, as well as separate varieties like overburden, K2 and K3. The same way you can view the same data for each level separately. This function helps to initialize the block model so that the designer proves that the analysis of the data of the real rock conditions on the layout sections. So after you create a section, you can snap an excavator and specify certain events for it. In this case, we specified that the excavator starts working at the beginning and at the beginning of the first calculating period, and we're specifying that this excavator works on the created section 1. In another column, we are indicating that the excavator capacity for different types of rock mass. For example, we can put overburden capacity as 1,000 cubic meters per day, and for ore K2 and K3, it's 2,500 tons. So in order to start the scheduling process, we basically should configure time intervals. And you will see on the video that we put the first day of the entire scheduling period, and the interval measurement unit, for example, 1 month, and their number, for example, 10 months. Yep, so you can see it on the video. Once you've done that, and once you set the minimum data that is required for our scheduling process, now we can make the a schedule for the operation of the excavator in this section. So we can see on the video, which is going to pop up right now. Yep. So you can see the results data in the table of the screen. And here you can see that, for example, on the level 12.5, excavator 1 will be working from January 1st to January 19th. And after mining this level, the excavator moves to level 7.5 and continues working on that level until the end of the month. The next month, it basically will start working on the same level. And after it is done there, the excavator moves on the level 2.5 and so on. So in the table, you actually can see the statistical data of how much rock mass volume will be mined in each of the periods. And based on that, you can calculate the average values of total and magnetic iron for each ore type for each of these periods. You can also calculate the final characteristic, like the sum of volumes, the total weight of ore K2 that will be extracted by this excavator, and the weight of ore K3 and other parameters. So now you can also visualize the mining order data on the block, and you will see how this section gradually changes its configuration. So there is the initial position. By default, the schedule method uses the creating stope method from those sections of the level that are in contact with the mine open pit space. So you can see that the section is mined in a way that the excavator moves along the conventional free boundary, and the excavator gradually uploads the blocks according to the specified stope width. And you can set the width of the section, in the section settings, and specify the width value of the excavator stope. For example, if the stope width is specified as 30 meters, you can look at the visualization of the results. Here you can gradually select blocks and create a stope that the excavator will actually repeat. So if you want to change the stope width, we need to specify a new value in the input field, for example, 10 meters. And we can reschedule and see how the stope configuration changes. You see that the volumes mined every day are grouped in 10 meters width blocks, and new groups of blocks are gradually opened. They are blasted and uploaded by the excavator. These groups are 10 meters wide, and the total mining time has not changed. It contains 6 periods, as the capacity of the excavator hasn't changed. Basically, you can see that the only stope configuration has changed, and the number of mine blocks is the same too, so the total work time remains the same. So of course you can actually create several sections, and we will see in the next video how in this case the blocks can be put together. In this case, so now we can create 4 more sections. Even if somehow we intersect the other section boundaries, it will not change the previously created section. The blocks that do not belong to section 1 are considered the blocks of section 2. If the blocks that are currently located on section 1 are considered the blocks of section 2, they are cut from section 1 and returned to the initial block model. Now, if we are deleting section 2, then the correct section 2 will be created instead. As a result, there are 5 sections for conventional OpenPit, and we can specify individual parameters for each of these sections and display the default parameters for all sections. So if you indicate a different worksite width or the amount of rock mass mined on the bottom level for any other section, you can change these parameters on a certain section tab. And now we're adding an excavator for each of the section, and after you do that, you have related each excavator to each section, and we can recalculate the work schedule. You will see that there are areas that overlay each other in some places. So to mine some blocks from one section, we will have to mine the blocks from another section first. So because of that, the work on certain section may be interrupted, and as a result, in section 3, the mining process begins a bit later, since there are blocks that you cannot mine until you get other blocks. Okay, perfect. So you'll see the process that I described earlier. So since you can specify the section configurations and snap excavators to them, you can specify various mining and technical parameters. And it's basically obvious that you can take into consideration menu scheduling aspects of section operation automatically. For example, if there are aspects that you can't deal with automatically, you can try to do it by changing the specified parameters. For example, the shape of the section, the events of the excavator, and other parameters. And you can select a separate section and assign it to be mined on a certain day after the specific milestone is achieved. Also, you can change and edit things like configurations of created section, its length, change the section vertex heights by shifting the upper or lower boundary section segments. So if you schedule this section now, you can see that the new levels are being mined and the mining period is increased to 10 months. And if you want to see the section status on the certain date, you just need to select it in the visualization dialog box and in the graphic field. So you can see that the indicated blocks are not mined on this date, and this way you can visualize the order of the mining process. By the way, the visualization also can be done in the reverse order, and you can see that the information on volumes, weights, and quality characteristics for the selected date input in the table dynamically. For example, we can select a small part of the overlay layer from the section 1. You will see it on the video. So after we did that, we scheduled the work of Excavator 1 so that it starts working on the new worksite and then continues it on the worksite 1. So the specified blocks of section 1 are assigned to section 6, and we can simulate the ramp cutting or other mining operations that will be mined separately from section 1. Then we can specify for the Excavator 1 that it must mine section 6 on the level 12.5. That should be mined first, and then it has to move to section 1. And after scheduling a new work plan of open pit sections, it is clear that the Excavator 1 first mines section 6 in 4 days. And then it moves on section 1 and will be working on it. So we can see one more case when the section is selected not from uppermost level of other section. For example, let's select section 7 from section 3 and Excavator 3 first mine level 2.5 of section 3 in 17 days. And then it started working on level minus 2.5 only on March 21st. And Excavator 6 will be working on level minus 2.5 on section 3 from March 13 to March 15. So if after the designer analyzes the schedule and thinks that it's not rational to select section 6 and 7, he can delete them and update section 1 and 3 respectively. Just a quick change of the video and we will see how this process is happening. Basically, the blocks that are cut on the second level of section 3 again correspond to it. So in addition to the beginning of the plan event, you can use also in a certain day event, which basically means that you can specify the day when the excavator starts working on the section. For example, you can plan that the excavator starts working after mining a certain section or after mining level of the section. And then if several excavators can work on the section, you can set that one of them starts working after mining a certain level. So it can be done with the same excavator or with another one. Plus, you can play around with the scheduling and say, okay, the work of another excavator should not begin after the full level mining and only after some part of it. This way, it can start working after mining 50% of the weight of the level 2.5 on section 1. Same way, as soon as the half of this level is mined, which can be indicated by weight, the excavator will start working. In addition to the stope width, you can indicate the number of excavators that can simultaneously operate on the section. Like in our case, there are 3 of them. And if the worksite opens for the excavator on the underlying level, the blocks on the side are scheduled for mining, and then the section is mined not only on the 1 level, but on maximum of 3. You can say that the ramp length also must be configured to move to the underlying level, which includes the simultaneous mining of several levels, or you can put the volume that becomes available after the ramp driving. So that will actually make the section mining on several sections rational. For example, you can configure a 100-meter ramp on the underlying level, and less than 50,000 tons of rock must become available for mining. And then you will see that you better wait until the overlying level will be completely mined, as the construction of this ramp doesn't make sense at that period of time. Additionally, you can change the sequence of blocks mined on a certain level. To do it, just go to Manual Settings tab and specify the worksite width and the stope displaying color. So we can see on the video that we can change the order of the level block mining. For example, you'd like to mine level 12.5. And now in schedule calculation and visualization, this specific section is taken into consideration. So you can see how with our model, you can schedule the work of the open pit in semi-automatic mode. And during this process, a specialist is in the loop of what's going on at all time. But we also have a functionality for automated scheduling. Basically, you can use it at subsequent planning stages, or if you want to plan in advance. What this function does is helping a user to evaluate how the schedule on volumes and quality every day or month is performed, and which areas of the deposit are more rational to mine in which volumes for a certain period. So let's see how we can determine the mining rock mass volumes from different sections to meet the scheduled operation indicators of the open pit. We can use the same generated sections as the source data, and you can see that there are available ore and overburden volumes at these sections. So you can schedule mining from each section of a certain part of rock mass for each period. In the interval tree, we creating the corresponding period and settings the scheduled indicators for the overburden volume and the ore weight. For example, we set in 25,000 cubic meters with a tolerance of 5,000 cubic meters for the overburden volume, and 36,000 tons with deviation of 6,000 tons for the ore weight. And now we can see that our algorithm recommends mining at the second and fifth sections that help you extract almost 30,000 cubic meters of overburden with 33,600 tons of ore. These indicators are within the limits that we have set, and if you want to use other sections, you can put a range of volumes from this section. For instance, here, to use the third section, we put the volume range from 1 to 4,000 cubic meters. And in the end, we got a new structure of production volumes. So in addition to the automatic calculation, you can change the configuration of rock mass mining on the section. For example, in the second section, mining will start on the 12.5 level. And it will be next to 7.5 level. You can actually reduce or increase the volumes that you have scheduled for mining by changing the pointer position. By the way, when you change the overlying level configurations, the volumes on the underlying level are synchronously changed as they become available if there is no mining on the overlying level. So now we are reducing the mining volume on level 7.5, confirming the received volumes on section 2, and recalculating everything considering these volumes. So this way you can analyze the results of the mining plan on the first interval by volume and quality indicators. Same way you can continue scheduling for the next periods. Keep in mind that the set scheduled characteristic may be different from the previous period plan. For example, let's put the overburden volume as 30,000 cubic meters and the ore weight as 40,000 tons. And then let's indicate the permissible deviations. you can see that the approximate calculation result on the screen and the second and third sections are recommended to be mined based on these calculation results. Let's also mine the first section. And now you have a new redistribution of volumes. So you can see that the third section is not facilitated in the OpenPit operation. If you need to speed up, then you can directly determine the mine zone type for it. In order to do that, you can perform mining in 2 stopes on level minus 32.5 based on the required parameters. This way you can change the volume according to the pointer position. If you need to mine both stopes, you can just set the pointer to the rightmost position and confirm the configuration and recalculate. After that, you can analyze the first, second, third, and fifth section mining recommended by the algorithm, as well as the obtained volumes and quality indicators. So you can continue the scheduling in the same manner on the subsequent intervals and performing the calculation automatically, specifying the additional indicators, changing the configuration of the section layers, and finally obtaining the required schedule values of the mining deposit interactively. So I think that's it. That's basically our brief overview of K-mine function, and we'll see if we have any questions here. I want to give the floor to Eugen, as he will be the one that will be answering the questions. Eugen, do you hear me?
Yeah, I can hear you, Anya.
Okay, perfect. So I just give the floor to you.
Mm-hmm. Okay. The first question was, is possible to make planning taking into account the elevation of the horizon of the query? So first of all, thank you for a question. And you can specify a list of horizons indicating the elevations of the upper and lower edges, as well as the angle of inclination of the range. Then the development of the query will be planned taking into account the entered data. Okay, the second question was, can you use stockpiles and buffering to minimize costs by pushing back non-critical activities to the last minute? Does the system allow to plan equipment repairs? So yeah, sure, we have a special input form for this. So we can easily manage equipment maintenance. So next question, how are the dates of explosions or planned repairs of equipment take into account? That's a good one. The user can form various directories indicating different types of data. These GITs can contain detailed information about the types of rocks, their drillability, explosiveness, bottom hole parameters, days off, etc. In this kind of reference book, the dates of explosions, their duration parameters of the work of queries during explosive days, during repairs of factories and equipment, and etc. can be entered. So can the excavator move between different areas? For an excavator, events indicate the possibility of its operation in several areas and at different time periods. The excavator can work sequentially in several areas. You can take into account the time of its travels.
Okay, perfect. I see that we also have a question from Pierre-Jean Lafleur. Hi, Pierre. Thank you so much for joining the stream. I see that the question is, can you use stockpiles and buffering to minimize cost by pushing back non-critical activities to the last minute? I will send you the answer to this question later after the stream, and we post all the questions on our LinkedIn page. So thanks so much for your question. We just need to have more time to analyze this question. So that's it, I think, for today. Thank you so much for joining. That was our brief overview of K-Mine functions to perform scheduling. Of course, it didn't include all the features of the model. We would like to have like a small quiz after the call, after this stream on our LinkedIn page. What kind of models would be interested to review during the next stream. Don't forget to follow our LinkedIn page, and hope to see you guys again. Thank you so much, Eugen, to participate in the event. I think that's it. Bye.